we're going to look at conditions of the different hypothesis tests and confidence intervals. So to start off with, we had our one prop z-test or z-interval. Our conditions for those were random or representative sample, 10%, which means our sample size must be less than 10% of our entire population, or you could say it that our entire population is probably at least 10 times the sample. Our last condition, which is the one that checks for normality, we do NP and NQ greater than or equal to 10, or in other words, the number of successes and the number of failures should be greater than 10. For a two-prop z-interval or z-test, it's pretty much the same, but we want to check those for both groups. So first we want two random and representative samples of their respective populations. We also want to know that our two samples are independent of each other. We check 10% for both groups, and we check our successes and failures NP and NQ greater than 10 for both groups. One side note is if you are dealing with an experiment as opposed to just a survey or whatever, we would check, instead of checking for random sample, we may check, did we have randomly assigned treatments, our groups to treatments. We wouldn't necessarily need a random sample for an experiment because we probably don't have one. We also don't really need to check the 10% rule for an experiment. Just whatever results we get, if it's an experiment, we wouldn't necessarily be able to apply or generalize to the rest of the population. So that is what that is. Our next thing was a one sample t-test or t-interval. This is for means problems as opposed to proportions. So we have the same random or representative sample. 10% rule is still applicable, but not really as necessary on means problems, so you don't really need to write that one. Normality, the way we check normality on means problems is one of three ways. We can look for were we given that the population distribution is normal. If so, we're done. If not that, then we may have a big enough sample size, bigger than about 30, and we're good. But if not that, then our last avenue to check for normality is to graph either with a box plot or with a dot plot, or maybe even a histogram on your calculator, the sample values that you're given and look for, is it roughly normal, meaning does it have any outliers? As long as it doesn't have any major outliers, then we're usually okay to say that normality is plausible. If it's a two sample t-test or t-interval, again, pretty much the same as one sample, just check for both groups. We again want independent or separate random samples, each representative of their own population. Normality, we would check, were we given that both populations are normal, is n greater than 30 for both groups, to the graph of both sets of sample data, roughly normal, or no outliers. Again, if it's an experiment, just check for randomly assigned treatments. If it's a paired t-test or t-interval, we pretty much treat this just like a one sample t-test or t-interval, but we use the differences between the groups. So we would look for one random or representative sample. They would not be independent samples, they are dependent, that's why we're doing paired. Normality, we would check the differences. So were we told that the differences is roughly normal? Were we told, do we have greater than 30 sample, or in our sample, and then are the graphs of the differences roughly normal? One of those three. Chi-squared goodness of fit test, this is when we have categorical data dealing with counts, and we have one row or column of observed counts, real simple. Random or representative sample, expected counts greater than 5, and that's it. For a test of independence, this is when we have multiple rows and columns of observed counts. We still just have one random or representative sample of its population. It just has multiple variables now, and expected counts greater than 5. For a test of, this one's supposed to say homogeneity, I forgot to change that. So for a test of homogeneity, we do have separate random samples. So we would be talking about how we have two or more separate random samples. And then expected counts greater than 5. Our last type of test is one that we typically skip conditions on. Regression t-test or t-interval, if you run across an issue where you have to check random sample, imagine that. We look at our scatter plot. Does our scatter plot look fairly linear, and does it thicken, meaning does it get kind of wider apart as we go along, or narrower? And then the last one would be check that our histogram of the residuals is roughly normal. You'd have to be given a whole lot of information in order to check those conditions, and typically we aren't asked to check them. So that is it.